Alright, you guys, so today we're talking about what special properties exist when the lines crossed by a transversal are parallel. So yesterday we talked about lines crossed by a transversal and how it creates alternate interior, alternate exterior, consecutive interior, and corresponding angles. So today we're talking about what happens if those two lines are parallel. So I'm going to start by doing a definition of what the transitive property is. Transitive. Okay, and the transitive property is basically like a form of substitution. So I'm going to write down an expression. So the transitive property says that if angle A equals angle B and angle B equals angle C, then angle A equals angle C. Okay, so basically this is I've called it the hamburger property before, because basically what it does is it takes out the meat in the middle and all you're left with are the buns. So since right here angle B matches on both sides, we can remove it and say that angle A equals angle C. It's just basically substitution. So instead of angle B, we substitute angle C. And that's what transitive property is. It just says that we can exchange an angle or a side length or whatever. And this works with sides too. This is just an example. So the transitive property says that if you have two things equal to the same third side, then those two separate things are equal to each other. Weird. Okay. So that's transitive property. So now I'm going to draw a diagram of two parallel lines crossed by a transversal, and we're going to discuss what the angle measures are inside it. Okay, a few things to note about my diagram. The transversal is line T, so line T is the transversal. Okay, the angles in the middle are 1 through 8. And then right here I marked with these arrows that these two lines, line S and line P, are parallel. Okay, so line S and line P are parallel, and line T is the transversal. All right, so then we're going to discuss what happens for corresponding angles and all those other things. Okay. All right, corresponding angles theorem says that if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So for this example, for this diagram up at the top, I know that since line S is parallel to line P, I know that corresponding angles are congruent. So I know that angle 1 is going to be equal to angle 5, because angle 1 and angle 5 are corresponding angles. They're both in the top left corner of their intersection. Okay. I also know that angle 2 is congruent to angle 6. Okay, because they're in the top right-hand corner. I know that angle 3 is congruent to angle 7. And I know that angle 4, I'm going to put it below, angle 4 is congruent to angle 8. All of these different angles are congruent because they are corresponding angles, and that's part of the corresponding angles theorem, okay? All right, I'm going to pause this, and I'm going to erase the corresponding angles theorem. So please make sure that you take a minute and you write down the corresponding angles theorem. And I'm going to erase it because I want to make sure that I can write the next theorem in that same spot. All right, so this one is the alternate interior angles theorem. And it says that if two parallel lines are crossed by a transversal, then alternate interior angles are congruent. So again, we've got some congruencies. So let's make our statement. So since line S is parallel to line P, we can use this theorem, and we can say that the alternate interior angles are congruent. So 3 and 6, angle 3 is congruent to angle 6, and angle 4 and 5.